Welcome back. Now we're going to go ahead and look at dependent probability. Okay, so this means your first event is going to change the probability of the second event, or the second event depends on the first event. Dependent probability. It's going to look a little bit different, but if you look here, we're still dealing with and. Okay, drawing two 8s, so I'm going to get an 8 and an 8. So when we have that and, the probability of A and B, but now they're dependent upon each other, what's going to happen is it's going to look like the probability of A times the probability of B given A. So this line here stands for given. It looks weird, feels weird, sounds weird, but bear with me. It's not terrible. Let's take a look. Here we go. So we're going to draw a king from a standard deck of cards. I'm going to hold the king in my hand. I'm going to keep it. And then I'm going to draw a queen. So just a little review here. In a standard deck of cards, you have 50 total cards. And you're going to have 4 of each kind and 13 of each suit. So a suit, that is, it's hearts, diamonds, spades, and clubs. So you have hearts, diamonds, a spade looks something like this, okay? And a club, some people joke and call it a puppy foot. Looks something like this. So there's 13 of each of them. These 2 are red, these 2 are black. And then you have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have jacks, queens, kings, and aces. So you have 4 1s, 4 2s, 4 3s, 1 of each suit. Okay, which is why you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's no 1s. There we go. The ace is your 1. Sorry about that. I'm here now. We're connecting. Okay, so the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, then ace, king, queen, jack. 13 hearts, 13 diamonds, spades, and clubs. So applying that to our probability here. The probability of drawing a king. There are 4 kings in a deck, 52 total cards. So that probability is 4 out of 52. And now I'm going to draw a queen. So if I'm holding the king, how many queens are in the deck? There's still 4. But if I'm holding the king, how many cards are left in the deck? Now there's only 51. There's only 51 because I'm holding one of the 52 cards. So that's the probability of A given B, meaning we know what happened we knew what happened during event A. Does that make sense? I hope so. Again, 4 kings, 52 cards. There are still 4 queens, but only 51 cards. And that's going to give me 16 over 52 times 51. That's 2,652. That should reduce here, so I'm just going to divide those, and I'm going to turn it back into a fraction. So this reduces to 4 over 663, which is about 0.006. So that is a 0.6% chance. Not very good odds there. Okay, does that make sense? Dependent. All right, one more here. Drawing 2 8s. So I draw an 8. There are 4 8s in the deck. So I'm going to draw one of them. So I am now holding an 8 in my hand. And I want to draw another 8. If I'm holding the 8, how many are left in the deck? there's 3. And only 51 cards. So this is the probability of B given I'm already holding an 8 in my hand. So 4 times 3 gives me 12. And then my 52 times 51 was my 2,652. Let's go ahead and see if we can reduce that. That's going to reduce to 1 out of 221. Wow, those are really low odds. This one is about 0.004 as a decimal. So that's 0.4%. Not even a 1% chance. Not good odds. Okay, we'll practice up with those, see how you're feeling.